Um, Hi, how are you? I guess we're closing to the end of the semester. That makes you very busy with many things. I hope you still survive. So as you can see that we only have two topics left over, which are ANOVA and regression, which is chapter 7 and chapter 8. And as usual, this the part will be more application rather than a proof. So basically, I would not have a proof, instead telling you how to use it and what's the meaning of that, how to operate that. It's more operationalized chapters. Of course, I will give some intuition why they're true, but I'm not going to do any proof because of the time. Just a quick announcement about the exam venue, because some of you told me that you want a bigger table because of open book exam. So that will be in the BMS basic medical building. That would be in the central campus. Okay, you can check that, and there's a link there, but it will be exam at that spot, so that I think that place can accommodate 100-something students. So you can separate with your and probably we will ask the TA to have a sitting plan after work. Then you know where to sit. Okay. And it's just very quick review what we have done, because today's the main goal is to finish ANOVA. Okay, very quick. Because I don't think we take a lot of time, because it's just a extension t-test from 2 group to a multiple group, right? I'm not going to review the hyper-testing, but the main idea hyper-testing is that we have to see, say, the simple case is whether the population mean equal to certain value in one sample case, right? Then if we know the population variance is z-test, otherwise the t, right? And the other thing we talk about is when we have 2 samples, right? We want to look at, say, are they have the same mean or different mean, right? And in the case we have 2, idea is whether they're same variance and they're different variance, okay? And we will keep the same variance idea when we do ANOVA. So this is something, how we can do multiple groups is to make some assumption there. So here we have to make assumption that in a standard classical ANOVA case, this is maintained, and we do multiple grouping. Okay, so basically is we extend this part to more than one group. Okay, and if you different group, okay, different variants, we can still do that when you have 2 groups. More than 2 grouping, we don't know how to do it, at least for our class. Okay. And then the proportion, the same idea, with different, the same, right? And then we learn that's a proportion, we use the z-test, right? And then when f-test, this is, yes.
Last class you mentioned we can't use the whole pool proportion for the difference between 2.
Yes, you can use p bar here, because why you can use p bar here? Because under the assumption that the same, so you can make it easier. But if not the case, you can't say that. So that is the main difference here. So that's same as when you have go back to here. When you have the different variants, you have to use this one. All right. But if you're able to make the same, then you can use this one. So that is the very simple assumption, because when you have the same variance, you estimate more efficiently. So that's why the standard error is smaller. So use the better one. I mean, always okay, you can use the bigger one, right? Okay, always you can use this formula, but this is bigger. You can show that this is always bigger than the case where you replace by p bar. Okay, so that's the main reason. So the f-test, this is the part that we will do, and you will notice that we will not use the 2-sided when we talk about ANOVA. We use one side. You will see why. Very quickly why we were using the right tail or left tail, depending on what you're looking at. But we'll use one tail for the ANOVA. Okay. Don't worry. The idea is very simple. Okay. The idea is just super simple. And as variance, I mean, we have ambitious goal. We'll finish this thing today. I mean, I don't think there will be too much difficult in this part. So we finish the one-way ANOVA before the break, and we'll do the two-way ANOVA after the break. So basically, just very simple idea extension of the two-way ANOVA. Okay. So as we said, we're looking at the following. We have a bunch of data, okay, and they're grouped by some grouping variable. And then we want to see each different grouping make a difference, right? In the case where we want to see the gender difference, which has been the case talking about the recent election result, people claim that more men is supporting Trump compared to more women supporting Kamala, right? Depends on. Or people look at white people are more likely to support Trump, and the people of color are going to support Kamala, right? This is something we want to look at, right? And different grouping is look at the result is they talk about the gender by age, or sorry, gender by race. So that also is two grouping. Okay, but that would be something without two way. So one way is just one type of grouping. Okay. So the main idea, as I said, is what we have is the observation. If you want to talk, can you keep the voice down a little bit? Yeah, it's okay to talk a little bit, it's fine, but just try to avoid talking too loud because some people want to listen as well, right? So it's okay. I mean, I think we can tolerate a little bit talk, but just keep it small. I appreciate that, thanks. So is the value of the grouping is the value and also the grouping. So basically every observation, okay, instead of just number, which we do in the last class, we know which group they are from. Right? For example, we have say X1 maybe how much money they spend, and then I know which grouping were female or male, right? Or I look at the question is looking at the GPA of the student and look at which college they're in, right? They may New Asia College, they may be a CC College, NC College, whatever college they are in, okay? And we know in advance what are the grouping is C of them, okay? So this is the data. If you call it, they call the long data. It's just collecting this way. Just the two column, the X is the values and G's are the grouping. So later you will see this how we import it in Excel. So one of the important part of this class is to understand how Excel works. And this is if you look at past papers, that's how what I'm asking you to understand the output. Okay. This is also asked in the assignment as well. Okay. So sometimes this is appear in this form. This is basically collapsing everything into a single vector, which means that x11 is the first observation from group 1. This is the group 1 last observation because n1 of them is from group 1. So this is collect them together. And you may ask why we write in this form. It is because this is convenient when you write equations, when you write formulas, okay? But that is shouldn't be a concern for you because just illustrate the formula only, okay? Is that okay? So you can imagine to rewrite this into the following. This is group number 1, group number 2, right? This will be x11 and x1n1, right? This is x21, x2n2, right? Do note that need not each column can have different number of total observations, right? So maybe you have more men than women. It's possible, right? So you don't have the same, okay? In the one-way ANOVA, there's no restriction on that. In the two-way ANOVA, we have to make the assumption of balance, which means each group is the same to make our life easier. But okay. Now, once we have that, so this is the form we set, the matrix form. We just seen it, right? There's different group, okay? Now, here we are just trying to understand, as I said, we want to understand is the population mean for each group are the same or not, okay? So the main idea is the classical is to assume they're all bell curve, okay? They all come from the same bell curve, but with different mean, okay? And do note that they're the same variance here, okay? They're the same variance here, okay? Same variance here, okay? They're different mean, but same variance. The same as I said, the t-test, because across group have the same variance, but I want to see the different mean or not, okay? So that is the main idea behind, okay? And to let me finish this part, okay? To illustrate, the something we write is the same mean mu, and this is this one, okay? Just to recall what we have done, okay? So remember what we have is the following, okay? X, the one group here, maybe this is boy, and these are girls, okay? The assumption we have is, say, the bell curve here. The girl will have mean mu2, variance sigma square, same, and the boy the same. Okay, this is actually what we have when we talk about two sample tests. T-test is here, right? This is a mu 2 and sigma square. Okay, and remember what we do is to test hypothesis. What we talk about is this is whether mu1 is equal to mu2. Okay, so that's the thing, and then we do a t-test, right? If you still recall how we do the t-test, is t is just x1 bar minus x2 bar, right? If you remember how we did it is sp square over n1 plus sp square over n2, right? And sp is the weighted average between the two, right? That is how we do. Okay, that's the t-test. Okay, and that is t to the n1 plus n2 minus 2, right? This is what we have did last week. So now the question is a little bit more complicated because I'm not limited to myself to two groups. Okay? In case I have three groups, say I have the same thing here. Okay, maybe somewhere here, I don't know where it is, but it's mu3 here. Okay, that's also sigma squared. They're same shape, but potentially different location. Okay, so the hypothesis I want to look at is this. Is it mu1 equal to mu2 equal to mu3? Okay, of course, you're more group than you're more, but only three cases like this. Okay, I want to see that the same mean or not. Okay, so that is the ANOVA idea, right? And it has a lot of application because you want to see different grouping of different, right? For example, in medical application, you have different treatment for the patients, right? You want to see whether you impose this drug, these pills make a difference, right? Especially cancer, you have different mixture of treatment, right? Cocktail treatment, right? Different combinations. And you want to see different combination would be different, right? Of course, you may say, why don't I do the t-test for each pair? Yeah, you can do it. But turn out it's more efficient to do it by f-test, okay? And turn out that it's the way we do, okay? And because t-test is do pairwise, but f is one, they have hold the same time. So it's more efficient, more faster. And this is the way we are doing our math, okay? So this idea, right? You just consider, and the observation is the mean plus an error term. This is the standard way, usually when we write, because this is the part shared across different observation. This only part different across different group, okay? And this the model that we will write is the decomposition, right? Or the random variable into two different components, right? And this is the part that is random, right? This is a random part, right? And this part is non-random, right? And this non-random part is something we can guess, right? This non-random part is something we can't do anything about it, okay? And of course, we can estimate that. That is easy to estimate, right? That is come from sample mean that we can estimate that part, right? And this sigma square you can also estimate as well, just by standard deviation of the group, okay? But that's the model, okay? So some terminology here because we want to say something a little bit more sophisticated, okay? And if you calculate this mean for each group and mean of all the group mean is called grand mean, it's just averaging group, mean of the mean within the group, right? And then if you define this way, we will have the mean of each group minus the overall mean is called the treatment effect, right? So let me draw this in the picture then to make sure that you know what we are doing, okay? In this case, right, the group mean is likely to be somewhere here. Right, this is the mu is here, right? Mu is somewhere here, right? And this will be the alpha 1, right? Maybe I use other color because I already used the red one, right? The difference will be alpha 1, right? And this is alpha 2, right? And this part will be alpha 3, right? So that would be the part. And when we say they're the same, actually we're asking ourselves is all the alphas are 0, right? So the question is alpha 1 equal to alpha 2 equal to alpha 3, that is 0, okay? And alpha or the treatment effect, right? So that means that we do intervention on different group, okay? And they want to see different group actually had the 0 treatment effect, right? The term comes from the idea, as I said, right? You do medical experiment, you do different type of experiment, you want to see whether they're same or not, right? So this is usually the first step, right? If they're all the same, then you don't need to consider the t-test, okay? So f-test is exactly what you do at the beginning, okay? You want to see if they're different. If it doesn't pass the test of the F, then you can forget about the t-test, right? You don't have to do group by group. So that is exactly what we're doing. ANOVA is the first round checking if you do different treatment. If none of the treatment are different, then you don't need to proceed the second step, okay? Once you show that they may be different, you can go ahead and do the t-test, okay? That is usually what we would do, okay? And we will see it in the next chapter when we talk about regression. We do f-test to see the regression will be meaningful, and then we go to the t-test. That's usually the step that we proceed, okay? Okay, so this is the treatment effect, that's what I said, okay? And that's the composition. The treatment effect must be 0, left and right, so because the mean, okay? So this is a graph, as I saw, right? So x1 is like this, x3 like this. You would make them all epsilon, the random part the same, and this alpha 1, alpha 2, and alpha 3. Remember, mu is the middle, right? So on the mu is the position where alpha 1 plus alpha 2 must be equal to alpha 3, okay? This is where the mean means, right? The left hand side and the right hand side are the same, okay? So alpha 1 plus alpha 2, the value should be same as alpha 3, right? This is exactly where the mu is. And now we go to the sample counterpart. And here is where we get the formula. And we tell you how to do f-test, okay? That's very simple. X bar is adding all observation divided by total of them, right? And this is exactly the one that would estimate mu, right? If you want to guess what the mu is, this is the one, right? And if you want to guess mu I, simply just look at group number I, add up all the observation, divided by how many of them, right? That's how we do, right? This estimate, the unbiased estimate of the mu I. Okay. Just add up all the observation in group I. That's the notation. Okay. And that's what I said already, right? And let's see the example to make sure they understand, because and that is how you understand the formulas, right? So this observation here, we have 3 groups of the observation. You can notice that we should write that down is n should be 12, all right? and N1 equal to N2 equal to N3 should be 4, right? And just the example, X11 is 1, right? And X22 is 4, in case you don't understand the formula. I hope this explains what the formula is, okay? The notation they are, I mean, you can write down everything there. And the grand mean is very simple, just add up total all of them divided by 12, which is n, right? This is n here. And similarly, you can do sample mean of group 1, it just add up all this number divided by how many of them. Okay, so basically we have all the formula there. I'm not going to go one by one. I guess this should be rather intuitive. Okay. Now what remains is to, as I said, we want to see whether the same population mean, whether grouping the same, right? And is the treatment effect the same? Okay, as the treatment effect is not the same, right? As I said, there's a used in experiment in science. We often, if you want to see they're the same or different, right? The medical. And in terms of business application, you want to see are the customer from different countries same, right? Different grouping or different grouping the same, right? Or you do a marketing, you have different marketing campaign towards different number of group people, then do observe the same, right? Then you can compare and contrast and see what kind of thing you should do, right? Or your management, your different management practice to every different group are they the same or not, right? Or simply, right, the easiest is portfolio, right? You want to see whether the mean return of different stocks are the same or not, right? Well, of course, data look different, but you want to test the same or not, right? So that the idea is you compare the variance with the F test. Why? Let's see the example, then you will understand what's going on. We are okay. So let's see the following. Okay. Maybe I tell you the idea first before we go to okay. So the main idea is the following. Do I have the graph? If I do, I don't want to draw it because let's see. Do I have the graph? Oh yeah, this is the graph. Let me draw it in case that will be easy. Okay. Don't remember the idea that we have is right. We have data here, right? And suppose under the null, right? It will be the case that actually everything is in the same graph, right? The red and the blue and the green actually there, the same thing, right? The same shape, actually locate the same location, right? There's no difference between them, right? Then that means when you collect data, it's the mu, right? The same thing, right? That means that when you collect data, when you look at data, it must be all the data be somewhere nearby here, right? When you calculate the variance, it should be something like that, right? But if they're not, right, that means that suppose the case is like this. Red, blue is here, okay, and green is here, okay. And now let's consider the following case, okay. You collect data for the red group. You calculate the variance within this group, say, right? And do the same for this group and the other group, right? You calculate variance within this group, right? And under the assumption here, right, within the grouping, you calculate variance within each group. They should vary close to sigma square, right? They should be close to sigma. They tend to be small, all right? They'll be small, right? Because within the group, the variance shouldn't be too much different, okay? That will tracking this guy. But remember, now look at the variance across group, okay? You're not comparing this. you're looking at the variance of the sample mean, okay? Because you collect the data, then will come up with sample mean somewhere here, right? Look at the variance across group, okay? If they're the same mean, then they also capture sigma square. But if different mean, they will be much larger than sigma square. So the main idea is looking at the variance across group, okay? Across group, across, maybe sometimes we call between, okay? And this is within, okay? Look at within and look at between. If they have different mean, then there's a different mean. That means that the between will be much larger than within. Okay, so that's the idea, right? Because they're different, then the between one will be much larger than within. So they wish F test to do it. Okay, so that's the main idea. Don't worry, we give the formula. It's a bit more complicated, but the idea is like if they're the same location, then there should be no difference between how you measure between and within, right? This is the same thing. Okay, but let us go into more detail, but I give you the main idea already. So look at the first cases. In this one, what we're doing is looking at each observation and subtract the mean. So basically, just look at the capturing the ideal variance, right? But if you divide it by n, is the variance of the forgettable grouping, right? If you divide it by n or n minus 1, n minus k, this is how we do it, right? But you divide it by that, that is the numerator part of the variance, right? Later we will see what you should divide, but this is the part for the variance. This total sum of square is the numerator of the part. When you calculate variance, if you forget about grouping, so that's called the total variance. Okay, total variation. Okay, and this is the part that between. That's what I said. Is you instead of looking at each observation, you replace it by the group mean. Why I do that is now I don't consider variation within the group. So everything in the group is replaced by the group mean. I look at how each group is different. So that's why I said between group. So this is the part that I just drawn is here, right? This is the SSG part. Okay, and this SSW part is within group. Okay, so that is the part that I have mentioned already. Is this part SSW? Okay, the formula is coming from the fact that instead of looking at this guy, you replace by each group mean, right? So looking at this one, okay? So SSG is replace the observation by its group mean and do the same thing, okay? This model, okay? So that is how we replace this. One is measuring variation between and within, okay? So by construction, this guy will be equal to this two, add up together, okay? So why we want to do that? Okay, very soon you will see why, but this is the first theorem we have. Okay, not very important, but you will see this is the part. So that's the idea, right? So this is the overall mean, right? This group number 1, group number 2, group number 3, right? And for each observation, you can calculate how it is different from the overall mean, right? And if it go into the center of data, that's SSW, I'll call it, take a square, right? And you square to here, between each group mean to the overall mean is SSG, okay? The idea is that if you measure variance using this part and use the variance measured by this part, they should be the same, right? Because this should be very close to this guy, right? But because they're different, because you're collecting sample, so there's a difference. But no matter how you measure the variance, because they're located the same, the variance should not be different. Okay, so that's why that's the idea, right? This variance measured by two-way should not be different. Okay, that's how we do it. So don't worry about that. If you don't really know what's going on there, okay, because the first thing to remember would be you know how to operate, right? And I hope you understand the idea behind. Because we're not talking about math, okay? Because to prove this guy require advanced math that way beyond our class, okay? I don't think in the B school everyone with no class, even you don't go to 4,000 class, don't explain that, okay? So I just give you intuition, that's it, okay? I don't think any math will prove anything in the undergraduate level unless you go to stat department, okay? So the good thing is understand what's going on, then that's it. So the only thing to understand is intuitively that's what is go, right? Because if they are the same, these to measure two weights to be the same, okay? And why? The math behind I don't explain, okay? But intuitively that's understandable, right? Because if they're different, this guy will be very large, right? You can imagine if they're different, this one can move to way further away. SSW is still the same, but this will be much larger, right? So this comparison did these two. So that is the intuitive understanding. And that's enough, right? Because no one will ask you further, okay? Unless you go to stat department, okay? So that's okay, unless you want to do stat, right? So let's look at this, how we do the calculation first, and then we tell you how to do the F-test. So that this is very simple. We have this, right? All the data here. We have just seen how to calculate in the previous exercise. How to do SST. You just take every data and subtract from the overall mean, take a square, do every one entry. This is how you get SST. Okay. 1 minus 4, right? That's how you tell it. And 1 minus 4, 2 minus 4, 4 minus 4, 3 minus 4, 4 minus 4. You go all the way, subtract each one from the 4, take square, this is SST. Is that okay? Okay. The sum of square total. Okay. And don't worry about the calculation. You only need that for your assignment. Okay, because I'll tell Excel how to calculate that. Okay. And assignment will ask you to replicate that. But other than that, I think this is the only time you do it. Okay. Because always Excel and click and comes out. Okay. But you understand what's behind, right? Because if you divide it by n minus 1, right? That will be the sample variance, right? That is the numerator when you calculate sample variance. Okay. And you can do the same SSG. How we do that? It's very simple. You replace all the data here, right, by the 2 here, right? Because I don't care about the variation in the group, SSU, across group, right? So when you replace this number by 5, right, because the group is 5 here, right? And you do the same for the last one by 5, okay? And you now once we replace it, you do the same operation as we just did, right? Subtract 2 from 4, subtract 2 from 4, subtract 2 from 4, so on and so forth. And 5 by 4 and do the same, 24. That's how we do across group, okay? Don't worry, you do it in your assignment. Okay, that's very simple. The last assignment is very simple, right? Which we'll release later. That will be just asking you to repeat this operation. The reason is you need to know what it is because it's very simple. Everything just Excel and comes out. Okay, so that's why I need you to understand what's going on there. Okay. So the last part is SSW within group. So that is not complicated because now I use this data. Instead of 4, I subtract the 2. So these 2 are here. Okay. I go here, go down. 1 minus 2, 1 minus 2, 2 minus 2, 4 minus 2. Okay. And I do the same for the blue. Okay. I go 3 minus 5. All right. 4 minus 5, 5 minus 5, 8 minus 5. And do the same for the green one. Right. And 2 minus 5. Okay. So once we have this, then we're ready to do the thing that we want to do. Okay. Then we tell you how to estimate the 2 different variants. Okay. Now here comes to the very last part. Is this. Okay. And we already said the MST is estimating sigma square, right? That's the part we mentioned already. Okay. This is the part that we mentioned already. Okay. And this, okay, is the part estimate based on the group, right? Y divided by this, because look at the difference between these two. So it's variance among the group mean, right? All the group mean there, many group there. Look at the variance of them. That's why C minus 1 there, right? Because the C group number there, right? And here the same, you look at the within group, there is SSW, okay? And there within the group, you look at the variance over there. And because estimate C of the mean, so you take C out of that, right? Because how many things you have, right? You estimate C of those, so that's Y minus C, right? You estimate 1, so you minus 1. Okay? So if you get it, you get it. You don't get it, that's the formula. Okay? I'm trying to explain that to you, but and turn out here comes to the very last slide. Okay? We compare MSG and MSW. Okay? And I'll go to this one, but this is most important slide. Okay, and we go back to how to calculate that. So is this F test. As I said, we want to see whether they're different, same or not. You just compare the group and within group, right? And if they are the same, then this whole, right? If they're not the same, it must be the case across group must be bigger than within group, right? As I said, right, they're different, then they're much larger. So it's a right tail test. Okay. But before we go about that, let's turn back to here. How to calculate that, okay? Here, the example we continue to calculate this guy already. Okay. And remember, N is 12, C is 3 because 3 group. Okay. So it's very simple. MST is N minus 1, right? N minus 1. And this is C minus 1. This is N minus C. Okay. And just the formula, right? There's nothing new there, right? There's nothing new to learn this one. Okay. So now we can do the final thing is to compare the two. Okay, this is the question. Last part. And we show you how to do it in Excel. So don't worry, we'll be very fast. So here with the data here, and we calculate MST, MSG, and MSW. Okay. And as we said, we want to use the MSG over MSW. Right? And the answer is 2 point something. Okay. And do note that what we check the table is look at F, C minus 1, N minus C. Okay, this is how we check. Okay, this table we check, right? And C is 3 and N is 12. Okay, so we just compare to this number, the critical value, which is F inward, because right tail test 5%, 2 and 9. That will give you this number, 4 point something. You can put it in Excel, okay? And remember what we're doing here. The F test is like this, right? And you tell me that this is 2 point something, okay? And what we found out that if we want 5% here, this number is 4, right? So that means that you don't have enough data to tell that there's a different grouping. Okay, you need more data, but of course that would be the idea. Okay, so this is the complete procedure to do it. Okay, but is that okay? Let me quickly show you how you would do Excel. Okay, because I guess that is the more important part than the operation. Okay, you need to do what I have shown you for the assignment, but here's the part that I will ask in exam. Okay. You operate this in the assignment or the computation, but this is something that usually you would do in exam. It's 1, 1, 2, 4. Okay. 3, 4, 5, 8, and 2, 4, 5, 9. Okay. Now let me save this file first, and then I will show you how I do it. So it's the data. Per now, you need just one click and we're done. Okay. So don't worry, this will be one click exercise. Okay, there's the data here. So how we do that is we have to go to data. We need to do data analytics. Okay. So you will be file, options, add in, and remember have to go and add the NS2 pack here. Okay. Once you have that, here is apply. I think we did that last time already. Okay. So what left is the very first guy, ANOVA single factor. Okay. And what we're going to do is we tell them the input range, which is very simple. You can just highlight this, or if you don't like highlight all the column, it's fine. Okay. Up to you what to do, but you just tell them what the data is, or you just want this is the easiest. Okay. Once you did that, you tell them the data is grouped by column, right? Because this is how we do the data, not by row. And that's labeled in the first row. Okay. And alpha is the p-value. We want the p-value, right? So significant level alpha, right? And tell them where we want to output their data. Simply, you just want it to here. Okay. Now, that's done. I click OK, then we are done. Okay. Ready? 3, 2, 1, go. Now, here's done. So this is the sum of SST, this is all the data. But the main thing is here. Okay. Here's all the main thing. Let me get it smaller. So here's the one that I expect you to know very well, because you look at the past exams, and this is where I ask. Okay. And you can see this SSW. This is SSG. The SST, you can see add up, give you this guy. This is N-1. This is C-1. This is N-C. This column over this column give you this column. This column over this column, this column. This column, this entry over this entry give this value. This is the p-value, this critical value, right? Just to show you again how do you get this is F dot inward 2, 9, sorry, 1025, 2 and 9. Okay. Sorry, should be this guy, right? P-value. Right. So just show you the formula there. Okay. So this is the one we mentioned. This is the p-value, right? And if you want the critical value, oh, sorry. Oh, sorry, I made a mistake. Should be the p-value, should be this guy. Because this is the part that right tail test, right? And the critical, how to get the p-value? P-value will be the F this, and then this number, and then 2, 9. True. Okay. And because this gives me the left hand side, I have to subtract from 1. Okay. So that is the formula there. Okay. So I hope you are able to tell me all the entry, right? I mean, because in the past paper, that's how I do, right? I just forget about some entry and ask you to fill that in, right? That is how you're able to do that. Okay. Because that's how I ask, right? Because understanding this table is a crucial for understanding everything, right? If you understand this table, you tell me the F test here, right? Under this case is 15%, so the p-value is not less than 5%, so you would not reject. All right, so you would have the hypothesis that they're the same. Okay, so now we have 3 different groups. So in the data, what we have is we don't have enough data, okay, to reject it, right? So the data support the null hypothesis, they're the same. Okay, of course, you make it longer, then we're different, and that is how we do, right? Do remember that it's very applied, right? Because you have give me data, right? Then I can just Excel and just finish, right? That's very easy and useful for your project as well, right? Always do ANOVA. That's the easiest thing to ask a question on. Okay, so this is the idea, right? This table, how to read the table, right? N1 over N2 there, this the right tail, the tail table, right? So you can look at this 2 and 9 will be somewhere this number, right? So that's how we create the table, the right tail. Okay, this is the idea behind ANOVA, but we are not going to do proof here. But you can check that is the simplest case that you can do it. Okay, there's a proof, but I'm not going to do any proof. Okay, and after the break, we go to two-way ANOVA, and it will be very similar. We just show you the formula, and that's it. Okay, because there's no proof behind. Just understand what we're doing, right? I hope that is clear. Just a final reminder before the break is we compare the variance calculated based on within the group and across the group. If they have different mean location, then this guy will be much larger than this guy. So then when you calculate the variance based on this over this, then it will be much larger, explode. Okay. So I hope it's clear. But in case it's not clear, ask me during the break, or you can ask in the you reply. Let's have a break of 15 minutes. We resume and then we continue.
Yes. Yes.
佢加咗就3分3。
Oh, sorry. A lot of jokes, but problems kind of hard to do. I forget what I was about it. Oh, books. Yeah, all many courses. But yeah, I got. 係啦，講老師啦，我哋用過你知道嘅，唔知道嘅，咁你點樣都有構成。Yeah, I mean, I actually had that. I think it's even for the same as well. 呢度就係咩嘢話？你唔知識埋佢，你唔知識乜就我哋呢度識冇簡單，因為寫到幾條，最多咁但係你個 bell 係 follow 真係，但係如果你唔知啦，你都所以就話所以佢發嘅你知道未？你知道乜嘢？你知道你唔知道咩事，即係如果佢本身我係本身佢係得啦，咁樣佢發到晒波邊咧，如果你選你咩？即係如果你知道你唔知道寫，你唔知道快嘅數，即係冇你食嗰啲。咁話當時呢個都我寫到500個500個，都係同啲多專業嘅。So I mean, you guys change. I mean, this is like, just like, I didn't want to come in. I didn't get it. Maybe oh, sure. Play basketball, yeah, I feel like Michael Jordan. We do play a lot. And I just overall grand different times. Well, với cuộc vui là gì em đi có thể I may say I like Wi-Fi. See, just several that's better. I'm trying to do that here. One of my That's what actually 20 well, actually, no, they don't like it. Zero B. Now what do you think? 你这个说比较大，就是我们在查提问，那个比如在要改一问题，Excel 嘅話有啲查提問，如果唔係到多個表，每個表要自己個表，咁對我哋呢個數啊，我哋睇翻嘅，我個 Excel 就係我哋咩都可以啦，所以呢個嘢所謂可以如果呢個數字經常你最多。答案冇嘅，答案冇嘅，答案只會俾嗰個教書剩下堂，剩翻一堂有報嘅，但我唔可以去 upload 呢個禮拜，source Excel 但係好講少數啦，你抄就抄啦，唔可以講少你第一個我都要抄你抄有啲問題呢度但係可以我先幾抄
Hi. Let's come back. Don't worry, the rest will be very simple. It's very similar. So just put in the formula, then you're done. Okay. Just try to give you some idea, but don't worry, it shouldn't take too much of our time. Because remaining this chapter and the next one, just put in the formula there, and then that's it. And look at Excel output and understand what's going on. Okay. Basically, just like I want you to understand how this formula behind Excel's and how to use the Excel output. And that's the best one you do, of course. It's good you understand what's behind, like why it's compared to variance. If you don't, it's okay. Because I do not expect you to explain, right? But you understand this tool is for that purpose. You understand what F-test is for, right? To see whether they have same mean or not. And why F-test work, why is F-test? You don't have to know. Because when I first learned it, honestly, I don't know. After many years, okay, I understand why it's behind. There's a lot of math behind. So I don't expect you understand just by some verbal explanation that it works, right? But if you do, that's good. If you don't, that's okay. Okay, it's more procedural stuff. And I think one more thing is people keep asking me when do assignment is when to use T, when to use Z when I actually go around. Okay, just to remember, let's go back to the slides. To make sure that you see what's going on. So here is the thing, okay? By construction, the sample mean, right, follow the central limit theorem, okay? Would tell you that this X bar we have do many times, right? This thing will follow a normal, right? You can use Excel to do everything there, right? And someone told me when you standard normal, right, is because of you would do this because this is how you check the table, right? And when you use T, right? T is the time where, remember, when you use T, because this guy is reasonable only if you know this guy. But the fact is you never know this guy in the real world. So what actually you do is, what we do is we look at this one instead. But this one does not follow normal. We're close to normal, right? It will close to the T table, okay? And that's how you look at the T table, okay? And you use Excel most of the time, right? But because of we can't use our computer, so you have to look at how to look at T table. So that is the idea behind unknown variance. That's how we apply, okay? And those of you ask the exam question, that that's what we do is I think is we'll finish ANOVA today, and then we will do regression for the upcoming 3 classes. And the 25th will be the second to last class. We go over past papers, and then we will exam. Okay. And then just to remind you, the past paper I release, I will not give out the written solution. So make sure that you're there on 25th. Okay, to drop down. Okay, the assignment. Okay, and for that class, I will not upload the video. Okay, there's a class we skip. Okay, so just this is the part that I can't do it. Okay, in case you're not here, make sure that your classmate have copy of what we said. Okay. So two-way ANOVA. So don't worry, this is very similar, very similar. But just one more thing new is at what we call interaction, which we'll define very carefully soon. Okay. What's two-way ANOVA? That is actually a very natural extension. Is each observation is characterized by more than one grouping information, right? Say, for example, in US, you can be female or male. You can be, of course, more genders as well, but you also have age group, or you can be represented by you're Republican, you are Democrat, or independent, right? Or even more groupings, right? Or you can be one of the 51 states, right? Depending on the state you live, right? That is these are a lot of information, right? Or in CHK, a student can be described by his college, his or her college, and also his or her gender. Right, so these are all faculties that he or she is in, right? So basically, there's a information. There's a two group, okay? And of course, this is the kind of data we have. Okay, each number will be accompanied by two information, which is grouping A and grouping B. Okay, and then we have C number of grouping for A. C stand for column, R stand for row. Okay. And the data look like this format, right? This is the most data. This is data that you collect, right? And usually can put it in the following manner, right? Observation 1, what number? 2, what number? 3 number. This is what we call the long data, and this is data that even appear in the data set. Okay, when I download data on internet, this is the one you have. But this one will not do the job. Okay, the one that we do will be the one we saw later soon. Okay, but here we have assumption that that make our math more easy is to assume we call the equal number of replicates, which means that each combination of the same number of observations. So that means that if I have male and female across, say, 8 colleges in CHK, I will have 5 men from NA, 5 women from NA, 5 men from CC, and 5 men from CCs, right? So equal number of observation for each combination of grouping. Okay, this is called M prime. So the data will be like this, a list, but easiest to look at this one, right? Say this is A1 have N prime observation, right? So same as the other one, right? So is the first element will be grouping first from A, right? Column C, right? There's A, C root of A grouping, and B grouping will be R of them. Okay, so this is the one that you use in Excel, which I'll show you soon. So don't worry about that. This is the part that I will show you, and then this is the data you input. I'll show you how to interpret that part. So don't worry, this part should be easy. So the model, as we saw, this is actually even more easier because this is more compact, right? Because everything for the bell curve with different mean, but they're the same model, right? But the thing is, here the mean would depend on two different groupings. So this is the model, right? Depend on which group you're in, right? Ith group and jth group. Okay? It means A grouping and B grouping. Okay. So this is math intuitively easy, right? This is random part, this is non-random part, right? But this is the part that not so intuitive. So this is the thing that usually we do. We decompose it, okay? And each mean will be an overall mean, grand mean here, okay? And this is the part that related to treatment from group A. This is treatment from group B. This is intersection of A plus B, okay? And this is a little bit more complicated, okay? Because this is impact from group A, this is impact from group B, this is how A and B affect, right? So here you can, A may be the impact of, say, men and women, right? Maybe men different from women. In that case, the alphas of men and women are different, right? If B are the colleges, right? And then different college will be different impact, right? And AB may be telling you that it may not be the case that men and women are different or college different, but in particular, maybe men in college A is better, right? Maybe woman in college D is better, okay? So it's interaction. It's not uniformly A is better, or uniformly men are better, or uniformly some college is better. Maybe just in particular, men in particular college is better, right? Then that may be something, okay? So it is possible that it's happening, okay? So that would be the idea, right? So, so that is the reason why we want to analyze two grouping at the same time, right? Because why you have to do this, right? The question is, why don't I do one-way ANOVA for men and women, done, and I want to do college and I'm done, right? Why I have to do two-way ANOVA? It's because I want to know the interaction. We look at, is it the case that, okay, we reject the idea that men and women are different, or we reject the idea college is different? But it is possible that it is possible maybe men in particular college are doing differently. Okay? So that is the main idea, right? We look at the election, right? We look at that men and women are very similar. White men and women are very similar for Trump, right? But for people of color, right, then men and women can be very different. Okay, so that would be the idea behind. Okay. So here we have some definition. Okay, and just for notation, nothing to explain. The first one is very simple, just mean of everything there. We just add up the mean, right? CR is the calculation, right? The definition. And mu I dot means that you forget about the college, add them up divided by R, right? Just add up every I group and look at all the R, okay? And dot J will be add up everything the J, but forget about the first group, okay? That's very simple. And that's how what we call the treatment effect is where they say men and women are different, right? And this is whether the college are different. And this is more complicated one. This is very complicated. I don't expect you to memorize it, right? You can see the main thing is to memorize the purple thing. And this is just a formulation, right? And this is the part where the interaction is the overall minus all the effect, right? So look at whether particular man and particular college will be look at the mean of this minus the overall, minus the effect of the man effect of particular college J, right? Give you this one. I understand there's a lot of formula, right? But I don't see the point of going very slowly because this definition. Okay, if you don't follow, probably you have to look at that carefully at home, check what's the meaning of that. Okay, and they're all definitions, so I don't know how to explain because this is just by construction. That's how you define those ideas, right? So here is the idea is very simple, just same as the mean, right? If you calculate the mean of everything, it's the autogram mean. Okay. If you keep the I there, okay, look at sum of all the JK is the A. So this is a little bit tricky. Let me show you what it means. Okay, it just means the following. If I add up all this average out, then will be X1 dot, right? Just the first grouping, right? Or if I sum of all this and divided by how many of them, right, will be X dot 1. Right, so that is the main idea there, right? If I everything add up and divide by all of them, that will be X bar. Okay? You can do dot dot, but we don't write dot dot there, but same idea, right? Is that okay? So that is the overall mean is adding up. If you have one dot with this one, right? If you the second column add them up, will be the two dot, right? And have this one. So that will be the idea. Okay. And do remind you that this is to measure the mu, right? And this is going to measure the mu dot 1, right? And this estimate of mu 1 dot, right? So that is how we define those. So quickly, you have the something like X bar ij, right? So basically, is this guy is X bar 1 1, right? Just focus on the group number 1 from A and group number 1 from B, and everything there with the mean. Okay. Now, once we have that, we can define all the thing we want. Okay, all the thing we want as the follow. We talked about that already. So let's do the calculation. So we have to do it. I think you will do it in your assignment as well. Okay, that's asked you to do it. So we just replicate this particular part, right? So I have 2 by 2 group here. Okay, the graph is adding everything up divided by total number of them. Total is n is 12, right? Add everything up, 12.5. Okay, and then how do you do? A is add up all this divided by total is gives you this guy, right? And if you add up all this divided by total number of them is gives you this guy, right? So this 1 dot, 2 dot like this. Okay, and you can do the B as well, right? If you do this group, will give you this answer, right? And if you do this group, will give you this answer, right? So that means that that's how you calculate this group means. Okay. Why I need that? Because once you need that, then we can do the following question. Okay. And finally, this is the within group. So this is here, right? And this guy will be here, right? And you do this one will be here, and this one will be here. So I guess it's too intuitive that I do it one by one, but you can go home and try, make sure that you, yes. Oh, because I want to estimate, say this is, say A may be man and woman, B may be NA or UCC, right? This is the mean of male in NA within the group. So this is the group. I just focus on, say, this is male, this is female, right? Suppose this is the maybe B school, right? This non-B school, right? And this means that I want to look at the average of male in B school. That's what I meant. And B12 will be average females in B school, right? And this will be the average male in non-B school, average female non-B school. And same as what we have seen before, if you look at this, right? This will be, remember this is B, this is NB, right? This is just the average in B school. This is the average of non-B school, right? Before will be the average male and average female. Is that clear? So just forget about this, how we do the grouping. So it depends on how refined the grouping is. You just, in terms of each group, you calculate the average. Okay, the dot means to forget about everything, right? So because 2 by 2, right? So this one is asking, okay, we take every grouping into account, look at each grouping, what's the mean, right? And this one is, I forget about the grouping of the A, which is male and female, we just look at the mean of there. And this one, I forget the grouping of the B, I look at the other grouping, okay? So that is how we do it. Why I want to do that? Because I want to ask the 3 questions there. As I mentioned, whether A grouping make a difference, B grouping make a difference, or A and group grouping maybe there's some combination that make a difference. Okay, so A and B is very simple. Basically, just one way ANOVA, right? Just you forget about one grouping, you can just do one way ANOVA, right? We know how to do it. And the last one, right? A, B make a difference. It's something new there. Okay, but don't worry, we'll show you how to do it in formula, and Excel just click and they're done. So that's very simple. So don't worry about that part. So the idea is the same, right? Because the idea is, again, is compare variance within the group and across group. Okay, the same proof to apply to solve the F test. Okay, of course, the proof is way more complicated. I don't think we ever learn it anyway, unless you are really step person. Okay. So the first one is rather simple. Is the numerator when you calculate variance, right? You forget about grouping, add up all the observation minus the overall mean and square, right? Just how we calculate variance, the numerator, right? And SSA the same, right? It's same as our SSG, right? But now 2 groups. They depend on which group we're doing, right? So this is, we look at the group A, right? Look at it, we replace every observation by group A mean, and this observation replace a group B mean, right? So this is SSG, but we apply to different group with 2 grouping, right? So this is SSG, okay, but different grouping. Later you will see the same formula there. The one of the most crazy one is this guy. I guess this is a part that every people stumble on, is this guy. Okay, this is the one that is SSAB, which is coming from, you replace the group mean, but you minus the mean of group A and minus the mean of group B and plus bar. Why is that? That's the treatment effect I mentioned at the beginning. That is measuring the gamma, right? This is the part. If you remember, this part is somewhat crazy because if you don't get this part, you can go back to here because that is how you calculate this part. Okay, but I'm not going to talk about those. Okay, and I think in textbook then they explain anyway. So if you don't want to understand, this is the formula and that's it. Okay, and you operate that because usually you don't really do the calculation, you just do Excel. But I try to explain what's behind in the darkened technical slide already explained to you. Okay. And the last one is nothing complicated. This is the SSE, right? Which is the SSW, right? Within group, you look at each observation compared to each group mean. Okay, this is SSW. Okay, and the three above is SSG, right? Turn out, not surprising, three of them, the four add up is add up to total. Okay, so of course there's a proof to do, but I'm not going to do any proof. Okay, instead I show you how to work out the math. Okay, and that is how we do. Okay, SST is very simple. You calculate overall mean there, right? You subtract every number minus 4.5, right? Go over every number. 4 minus 4.5, still 1.5, so on and so forth. Okay? You can check it out. It's not complicated. SSA is simply replace this by its average in this column, which is 3. Replace everything by 3 and subtract 4.5. Okay, become 3, 3, 3, 3, 3, 3 here, right? And you replace this number by 6, right? So that's how you get the second part. So that is the idea behind. Okay. So if you don't get it, don't worry, because you will do assignment, then you know how to do it. Okay. That's you always remember how to do it. Because only by working the assignment, you know what to do. Okay. And because just applying a formula, I don't think it's worth our class time to go over every single entry, right? Because just applying the formula there. And SSB the same, right? So what we're going to do is replace this number by x dot 1, this is 5, right? And you replace this number by 2, by 4, right? So just do the same again, subtract from this guy. This gives me SSB. Now that is okay. Now the crazy part comes in, SSAB, which is something completely crazy, okay? But don't worry, you will do it once in your lifetime, your assignment, right? Only the once time, okay? So it will be, you take this value, this guy, you will subtract its column mean and subtract its row mean and add back the overall mean, which is not something too crazy. Okay, you do the same. Subtract this one, do the same, right? And this one will be, you take the value, right, and subtract its column mean, 6, subtract its row mean, which is 5, right, and add back the overall grand, it's the same. Okay, so if you in doubt, go back to this slide and you're able to do it. Okay, as I said, you only do it for one assignment once, right? Because you use Excel to handle this anyway. And SSE is rather simple because you know how to do it SSG, right? All this number subtracted by its group mean, right? Do the same, right? So this is 4, 4, 4. Right? You look at this 5, 5, 8. The mean is 6, right? So you just subtract each number by 6. You see. Okay. So you do for every entry. Okay. Now we have SSA, SSB, SSAB, and SSE. And then we'll do the MSA, MSB, MSAB, and MSE, and that's it. And do the F test. That is the same thing. Okay. So we can show that the same, but here comes the very last, second to last slide. Okay. MSA, MSB, MSAB, and MSE. Okay. And you just, there is a C number of A, so that's Y minus C minus 1. And there's R group of B, that's R minus 1. Okay. And you will have R minus 1 times C minus 1 because you estimate R and C mean, so that's why you have to subtract. And MSC will be a little bit more complicated the same idea, but this is the thing. So of course, you may hate this slide, but here comes the important slide here. You can do the calculation, which I'm not going to bother you with that. But let's look at the most important thing. So here is how you compare. Okay. Again, remember how we do it. It's compare the group, right? Over within, right? So this is MSG over MSW, right? MSW over MS, right? So this MSA over MSE. Okay. And if you look at B, it will be MSB over MSE. We look at C, AB will be this one. Okay. So the idea is you want to see the group A the same, MSA over MSE. You look at whether B is the same, MSB over MSE. You look at group RC with MSAB over MSE. Okay. And the table to check will be C minus 1. This little bit more complicated is RC prime minus 1, or this guy. Oh, this is a little bit more tricky. Okay. And you can do the calculation here, right? Do the MSAB over that, right? So I think you can check these guys out. I want to show the Excel because this is the most important. You always do it in your assignment anyway. So I want to show you the Excel, which I asked in the exam. So that's more important. I think you can do it this one will be very similar. So I'm not going to bother with that, but instead I'll go to the Excel to show you. So that's how I do the Excel part. So let's see. This is 4, 0, 8, 5, 5, 8. Oh, that's here. 3, 3, 0, and 9, 5, 5. Okay. A1, A2, B1, B2, B2, B2. Okay, so this is same as the slide here. Okay. And then with the grouping. Okay. So this is exactly the same that we've seen already. Okay. So what we're going to do is show you the Excel. Okay. Data analysis. And we will choose the one that is two-factor ANOVA with application. Okay. Input range is just this one. Okay. And how many row per sample is you have 3 row. Okay. And you tell me where to output, then we're done. Let's see. Is there any problem with that? Okay, let's do this one. I cannot use the co-column, but anyway, it's fine. So this is all the summary, and important part is this guy. Okay, this is the part you expect to know where how to handle that. Okay, and so this is SST, right? And this is SSE, right? And this SSAB, right? And this little bit, yes. And you have SSA, SSA 27. So this is SSA, right? And this is SSB. Why? Column is A, right? And the sample is the B, right? And this part is SSAB. Okay. And this part is SSE, right? And this guy is SST, right? SST, right? And this is C minus 1. This is R minus 1, right? And this is RC M prime minus 1. M prime is 3 here. Okay. So it's 2 times 2 times 2, right? And interaction, remember, is what? Is R minus 1 times C minus 1, right? And this column over this column in the F divided by column of G is the column of H, right? And if you divide this by this, give you this one. Divide this by this, give this one. You divide this by this, give you this one, right? And finally, that's how you calculate this number. For example, this number is coming from the fact F this, okay? And you have this number, the degree of freedom will be 3 be 3 and sorry, it will be 1 and 8 because 1 is this degree of freedom here, 8 is here, right? And then true, okay? Do reminder is right tail, so 1 minus. Okay. So this 2 you can easily get it, right? By simply changing this 1 to the same, okay? And that's how you get this number and the critical value the same. Okay. So the key part is you understand this particular table and you know from Excel how you derive all of them, right? And you can see from this exercise, first hypothesis 1 is grouping A make a difference. No. You use 5%, no. Use 10%, yes, but 5% is no. Okay, because p-value is less than, is bigger than 5%. Grouping B, does it make a difference? No. You don't have anything to say, so not the same. Is A, B make a difference? No. Okay, so that means that they're all the same. Then you're happy. Okay, forget about the grouping, then go on and do whatever, right? Because in marketing, right, probably you look at different grouping. Is it different grouping the same? The same, then you can just apply uniform policy, right? Uniform marketing strategy. If they're different, then you probably apply different strategy as well, right? So that is the main message, right? You need to know how to handle this, but don't worry. This is the question we often ask. Look at how to look at this one is the most important, right? Because look at Excel is the most important. And how to calculate that is your assignment, right? Well, I'm not going to do calculation in the exam, right? That's unlikely because it's too much, right? So most likely this is the one that I've been asked in the many past year paper. This is the one that you should know how to do it. If you don't know, then I can't help you. But this is the minimum is you can see the past paper, it will be I just hiding some number, you figure out the rest, right? Because I hide one number, you can figure out the rest, right? Shouldn't be difficult, right? At least you know how to Excel the calculation, right? Maybe the p-value and F I don't, right? But the column F, G, H, I hide any number, you should be able to calculate, right? And J and K, there's a formula from Excel to there, right? You're able to get it out. Okay. So that will be the end of today. So I think you're done with the ANOVA. So we will be doing regression next time, because there's nothing except the Excel table and the calculation is there. It's basically computational class. So same for regression. So don't worry, I will see you next class. See you on Wednesday.